For centuries, Saturn's rings seemed almost impossible. They stretch hundreds of thousands of kilometers across space, yet from Earth they appear as a thin, perfect disk surrounding the planet. By the time the Cassini spacecraft arrived at Saturn, scientists thought they understood these rings better than almost anything else in the solar system. After all, they had been studied for decades. But there was one place nobody had ever looked: the narrow gap between Saturn and its rings. In 2017, Cassini was sent directly through that region for the first time. Scientists expected to confirm what they already believed about the rings. Instead, the spacecraft revealed something surprising. The closer it got to Saturn's rings, the stranger they became. Cassini's mission was always going to end at Saturn. The spacecraft had been operating for 13 years and was running low on fuel, and rather than risk an uncontrolled crash that could contaminate one of Saturn's moons, mission planners designed a final phase called the Grand Finale, a series of orbits that would thread Cassini through the gap between Saturn and its rings before sending it into the planet's atmosphere. Nobody had ever attempted this before because the region was considered too risky. The rings are made of countless particles ranging from dust to boulders, and flying through any part of them at orbital speed could have destroyed the spacecraft instantly. The gap itself was assumed to be relatively empty, a buffer zone between the planet and the inner edge of the rings, and that assumption is partly what made the maneuver possible at all. What Cassini found in that gap during its first pass immediately complicated the picture scientists had of how the rings interact with the planet they surround. To understand why what Cassini found mattered, it helps to know how settled the science around Saturn's rings was before it got there. The rings had been observed for over 400 years, and the prevailing view was that they were ancient, formed from material left over when the solar system was still taking shape, and essentially stable. One of the first things Cassini's final passes allowed scientists to do was weigh the rings properly. By measuring how Saturn's gravity affected Cassini's trajectory as it passed close to the rings, scientists could calculate the total mass of the ring system with far more precision than any previous method had allowed. The result was a mass significantly smaller than expected, roughly equivalent to the moon Mimas, and that number created a problem, because a ring system that small couldn't have survived for billions of years. The particles that make up the rings are constantly colliding and being lost, either falling into Saturn or drifting away, and a ring system with this little mass would have eroded into nothing long before now if it had been around since Saturn formed. The math only worked if the rings were much younger than the planet they surround, somewhere in the range of 100 to 400 million years old, which meant Saturn existed for most of its history without the rings at all, and something relatively recent, in planetary terms, had to be responsible for creating them. The leading explanation involves an object that no longer exists, a moon or a large icy body that drifted too close to Saturn at some point in the last few 100 million years and crossed what's known as the Roche limit, the distance at which a planet's gravity becomes strong enough to overpower the object's own structural integrity. Past that point, the object gets torn apart, and the debris from that destruction would have spread out into orbit around Saturn, eventually flattening into the disk that became the rings. The composition fits this explanation well, because the rings are made almost entirely of water ice, which is exactly what you'd expect from the outer layers of a shattered icy moon. What's still unresolved is what that object actually was, and what caused it to drift close enough to cross the Roche limit in the first place. Whether it was a gradual orbital decay or some kind of gravitational disturbance from one of Saturn's other moons. And that question remains one of the open threads Cassini's data left behind. Long before the grand finale, going back to the Voyager flybys in the early 1980s, scientists had noticed faint radial markings appearing and disappearing across the rings. These were named spokes, and for decades they were treated as a curiosity rather than something that needed a full explanation. Cassini observed them in more detail and confirmed they were tied to Saturn's magnetic field. What made this significant wasn't just explaining the spokes themselves, it was what they revealed about the rings, that the particles making them up are sensitive enough to Saturn's magnetic environment to visibly shift position, which meant the rings were much more dynamically connected to the planet than the static picture from before the grand finale had ever suggested. That connection between the rings and Saturn goes further than the spokes. During the grand finale passes, Cassini was close enough to detect something that no previous measurement had been able to confirm: that the rings are actively losing material into Saturn's atmosphere. Particles are being pulled inward along Saturn's magnetic field lines and falling into the planet at a rate that, when Cassini's data was analyzed, turned out to be higher than anyone had estimated. The term that came out of that analysis was ring rain, and the name understates what it actually means, because at the rate the rings are losing mass, they have a limited future. It's suggested that the rings could be gone on a timescale that is short by any planetary measure. And when that finding was put alongside the discovery that the rings were young to begin with, the picture that emerged was one that nobody had anticipated going into the grand finale. Saturn has existed for what's said to be over 4 billion years. For most of that time, there were no rings, and at some point, they will be gone. So the version of Saturn that every person who has ever looked through a telescope has seen is not the permanent feature it was always assumed to be. What Saturn looks like without its rings is something most people have never considered. Strip the rings away, and what remains is a gas giant, with cloud bands and storms running across its surface, recognizable as a planet, but nothing that would stop anyone in their tracks. The rings are the entire reason Saturn is Saturn in the way most people understand it. The reason it has been the most visually striking object in the solar system since the first telescope was pointed at it in 1610. The spacecraft that found out they weren't permanent was sent directly into the planet that will eventually be left without them. On September 15, 2017, Cassini was deliberately steered into Saturn's atmosphere, with the mission becoming a huge success. 13 years of operation had exhausted its fuel reserves, and with no way to control where it would eventually end up, mission planners made the decision to end it on their terms, rather than risk an uncontrolled collision with one of Saturn's moons, several of which Cassini itself had revealed as potentially showing conditions suitable for life. The final phase was called the grand finale because it ended with the spacecraft becoming part of the planet it had been studying for over a decade. As Cassini entered Saturn's atmosphere on that final morning, it was still oriented correctly, still sending back measurements of the atmospheric composition it was passing through in real time. The signal took 83 minutes to reach Earth, and when it cut out, the mission was over. The mission that rewrote everything known about Saturn's rings ended inside Saturn itself, and the data it sent back in those final minutes before it broke apart added one last measurement to 13 years of findings that are still being processed today. If you made it this far, be sure to drop a comment on what you think created the rings in the first place.